do some more work with the chain rule. And just to point out a couple of important dates coming up, the 19th is your next take-home quiz and your project check-in day. So you want to make sure that you've done as much as you can on the drum roll project before the 19th. You do have, again, a suggested timeline for on the front page of the project, sort of to keep you on track. But you actually know everything you need to know to do the whole project now. So like, don't feel like you have to hold yourself back. And then your steel drum project is due on the 26th, and the test 2 is November 2nd. Oh, I did have one project with no name on it. Somebody didn't get their project back that expected to. That you? Yeah. Just throw your name on it and give it back to me, and I'll put it in the computer. Second. Okay, so today we're going to expand our ability to use the chain rule to differentiate, and we're going to differentiate functions that are defined numerically as opposed to just being given a formula. Okay, and we're going to be able to take compositions of more than 2 functions. And in your activities, you'll learn how dogs do calculus. Okay, so sometimes we have to apply the chain rule repeatedly. In the process of multiplying by the derivative of the stuff, right, which was the chain rule that we learned last class, sometimes you have to use the chain rule again to take the derivative of the stuff. So here's an example. I have e to the sine of the 2x minus 4 cubed, right? So it's a composition of many functions. A reminder from last class, we haven't talked about why these formulas are yet, but the derivative of the sine function is the cosine function, and the derivative of the natural exponential function is the natural exponential function. All right, so let's think of this as y equals e to some stuff, right? So the derivative of e to some stuff, so I'm just going to write this out in many steps. You don't have to write out all the steps when you're doing this, but for the first few, I'm going to write them all out so that you can see exactly what I'm doing. So I'm just writing out the derivative of e to the sine of 2x minus 4 cubed. Right, so that's the thing I'm trying to take the derivative of. Okay. The derivative of e to some stuff should be e to the stuff times the derivative of that stuff. So the derivative of e to all this junk is e to all that junk times the derivative of the stuff, right? And the stuff is the sine of 2x minus 4 cubed. Okay, so far? I didn't even try to take that derivative. Yesterday when we were doing the chain rule, instead of writing down the derivative of the stuff, I just took the derivative and put it there. But because this derivative is pretty complicated, I wrote e to the stuff times the derivative of the stuff. And in the next line, I'll start trying to take the derivative of the stuff. All right, so in the next line, I'm just going to copy my e to the stuff, e to the sine of 2x minus 4 cubed times. Okay, so now I want to take the derivative of the sine of some stuff. Okay, so the derivative of the sine of some stuff is the cosine of the stuff times the derivative of the stuff. Okay, so this is going to be e to the stuff times the cosine of the stuff times the derivative of the stuff, right? And in this case, we did the cosine of some stuff, so we take the derivative of 2x minus 4 cubed. So I'm not done with the chain rule, right? I still, in order to take the derivative of the stuff, I have to use the chain rule again. And I'm going to have to use it again. Actually, rather than squish this, I think I'm just going to put it on a new page. Okay, so that's just the previous line. You copy the stuff you already have down. E to the sine of 2x minus 4 cubed times the cosine of 2x minus 4 cubed times. Now I have to take the derivative of some stuff cubed. How do you take the derivative of some stuff cubed? Apply the power rule to the stuff, and then multiply times the derivative of stuff. So I'm going to bring the 3 down. 2x minus 4 squared, and then times the derivative of the stuff. And then what's the derivative of this inside stuff? 2. That's it. So there were just so many functions inside of functions that every time we applied the chain rule, you ended up having to do the chain rule again to take the derivative of the stuff. So any questions? Yeah. I was applying the power rule to 2x minus 4, right? Let the 3 down, copied 2x minus 4, raised it to the 2. Then the chain rule says, then multiply by the derivative of the stuff, right? The derivative of 2x minus 4 is 2. Yeah. Yes, first you apply the power rule to the stuff, and then the chain rule says, after you've done the regular derivative rule, you still have to multiply by the stuff inside, by the derivative of the stuff inside. Yes. Way of writing it. Sure, like I could have done it all in one line. With a little practice, I could have jumped right to this. Like I could have said, okay, well the derivative of e to some stuff is e to that stuff. And then I would look at the stuff and say, okay, this now I have to take the derivative of this. The derivative of the sine of some stuff is the cosine of the stuff. And then you look at the new stuff and you say, okay, the derivative of that is this. Right? And you can write it all down at once. Yeah. Is there an actual word for stuff? A lot of people call it the inside function. Okay. Yep. The inside function, or yeah, use that. U and Z. Yeah. Yeah, they just name the functions. Like in this case, I had a composition of 1, 2, 3, 4 functions. So I would have named them like F, G, H, and K or something. Yeah. All right, so that's a pretty complicated example. And then here's one that we defined numerically. So I didn't give you any formulas. I've just given you a little chart with some values of F and G and F prime and G prime. You've done something similar to this before with the product and quotient rules, but now we're using the chain rule. Okay. So I want to find the derivative at x equals 1 of this function, f of x squared minus 3 times g of x squared. All right, so I want to take the derivative of what's in these brackets here. So I have f of x squared. That's some stuff squared, right? How do you take the derivative of some stuff squared? Bring the 2 down, copy the f of x, reduce the exponent by 1, which is just the first. Okay, but then what do I still have to multiply by? The derivative of f, which I'll just call f prime, right? Because I don't have a formula, so I'll just call it f prime. So I applied the power rule to f of x, and then I multiplied by the derivative of the inside function. Okay. Minus 3 constants just always come along for the ride. You can just copy them down, right? And then I have g of some stuff. Okay, so I want to take the derivative of g of some stuff. So my inside function is x squared. My stuff is x squared. My outside function is g. So I don't, because it's not a formula, I don't have a derivative rule, right? Like what's the rule for taking the derivative of g? It's just g prime, right? So this is going to be times g prime of x squared, right? Take the derivative of g, evaluated at the inside function, and then times the derivative of the stuff, which is 2x. Yep. Good. So that's, I've applied the chain rule to both of these, and I've got a formula for my derivative function, and then I plug in a 1. Okay, so I'm going to have 2 times f of 1 times f prime of 1 minus 3 times g prime of 1 squared times 2 times 1. And then I can look up all the values I need for my table. So f of 1 is 1. Is f prime of 1 3? Yeah. Yeah, but I haven't plugged it in yet. Yeah. Just writing it out. Yep. So f of 1 is 1. F prime of 1 is 3. 3 times 1 squared is 1, and g prime of 1 is -1 times 2 times 1. So 2 times 1 times 3 is 6. And then we have -3 times -1, which is 3, times 2 is 6, plus 6 is 12. Or you could have said it's subtracting -6. Same thing. Because this is a subtraction sign right here, right? From right here. Times 2. Yeah.
Why is the 1 negative? Yeah.
Why is the 1 negative? G prime of 1. G prime of 1.
Yeah, on our sheets, those are boxes.
Oh, it printed weird.
Yeah,
Sorry. Yeah, it printed. All those little boxes should be negatives. Fill those in.
Except for where it's prime.
And those should be primes. Yep. Yep, the little boxes in the top row should be primes. Go back to where? From my table, I looked for x equals 1 under f of x, you get 1. X is 1, look in the f of x column. So I looked up all the values in that table, right? If I wanted f prime of 1, I look in the 1 row, the f prime column, you get 3.
In the first row, three terms in, where do you get the f prime?
This right here?
Yeah.
So that's the chain rule, right? I applied the power rule to f of x, spread the 2 down, copy the f of x, reduce the exponent by 1. Whatever you're copying, right, you still have to multiply by its derivative. That's the chain rule that we talked about last class. Right, but we didn't always call it f. Like if I had a formula for f, like 3x plus 4 squared instead of f of x squared, when I take its derivative, it would be 2 times 3x plus 4 to the first times 3, right? The derivative of the inside. But because I don't have a formula for f, I couldn't write down a formula for its derivative. I just wrote down f prime, a symbol for its derivative. I don't want you to simplify it. No. The only reason you would simplify is if I asked you to find the second derivative, right? You might want to simplify before you start to make your life easier. Or if you can simplify in 1 or 2 steps and make it look a lot cleaner, do it. Like canceling an x or doing a 2x minus 2x, like those should go away. But if it's going to take you a page and a half to simplify, don't bother simplifying. All right, so you got some to work on.